Hello, welcome to today's lecture. We are on lecture 2. We're still covering chapter 1 or module 1. So let's review what we learned so far, then we continue the rest of module 1. We learned about statistics, as a branch of math. And we learned that statistics include some steps. The first step is to ask a question. After asking a question, we're interested in targeting the population or sample, collect the data. After collecting the data, we're interested in to find pattern in our collection. So we try to visualize the data. After visualizing the data, we're interested in having numerical characteristics for our collection. So analyzing the data. And finally, we're interested in making conclusions or inferences about other collections, about our population, and so on. We learned that population is the big collection, including every data. It includes the entire or every little bit of piece of information in the collection, and any sub-collection or portion of population is called a sample. We talked about different type of research questions. We also talked about cause and effect, relation between two variables. We also talked about different variables in a study. Very well. Remember that we have two types of variables. The first type of variable is called dependent. The other one is free or independent. Another name for dependent variable is response variable. Independent variable or free variable is also called explanatory variable. Well, let us take a look at one example in the note. We are on page 7. We're actually done with page 7. We are moving on to page 8. Very well. In this question, we have a study. As you read the problem, think about the following statistical ideas. First of all, the population of interest. The second, the variables being studied. And finally, the type of research question that is being asked. Researchers wanted to know if people think a task will be hard to accomplish when the instructions are difficult to read. To answer this question, researchers randomly divided 20 students volunteers into two groups of 10 students each. Researchers gave instructions to each group of students using different fonts. Instructions for one group were written in a large upright font. The other group was given the same instructions, but in a font that used hard-to-read italics. Researchers asked students to read the directions and say how many minutes they thought the task would take. Researchers did this in order to figure out if the fonts used for the instructions made any difference. So the first font, this is the easy to read upright font that was used in the study. And the second one, as you can see, it's a little bit harder to read. The first group of students, those that read the instructions printed in the easy font, had an average time estimate of 8.23 minutes. The other group, the group that read the instructions in the hard-to-read italic font, had an average time estimate of 15.1 minutes. So see, there is almost 7 minutes difference between these two. Very well. Researchers concluded that such a large difference between the averages was not likely to have occurred by chance. There was evidence that people think a task will be harder when instructions are difficult to read. Very well. Part A. What is the research question being asked? B. Does the study ask a question about the population, or is just a case of cause and effect relation between two variables? C. What's the explanatory variable? What's the independent variable? And D. What's the response variable? What's the dependent variable? Let us go over solutions together. So this is, try it on page 8. This is 22. Okay, part A says, what is the question that is being asked? B, the question says, does the study ask a question about population? Is this about population? Is this asking about in general, it's hard for everyone, or it's easy for everyone, or is asking about the question between two variables, or cause and effect? Different fonts impact the time of performing a task. C, it's asking about the explanatory variable. And D is asking about the response variable. So what's the question in general? So you can say that, do directions or instructions in general in a hard to read fonts cause people to think a task think a task is harder to perform. This can be your question, statistical question. Then, of course, it's cause and effect. The cause of having different thoughts and effect in thinking a task is harder to perform. What's the explanatory variable? What's the free variable here? We are changing different fonts. So fonts in general are free or explanatory or independent variables in this case. And response is the amount of time to perform the task. That takes to perform a task. So when it comes to study, statistical study, we have two types of studies. The first one is called observational study. And the second one is called experimental study. So the main difference between observational study and experimental study is that in observational study, you don't have any treatment. You just go and find a random sample, ask question, write down the answers or the records, and you're done. In experimental studies, however, it takes time because you have to have a treatment for a sample. So it includes treatment, a change to a variable, and finally, measuring the response variable. So in general, when it comes to experimental study, you say you have the case of cause and effect. In observational study, you usually just go around and ask questions. For example, one type of observational study question can be, okay, what was your SAT score? You find a sample and you ask question, you just collect the data and you're done. In experimental studies, for example, you have a new cure for cancer and you want to test that if that, for example, new drug or treatment is effective or not. So we are on page 11. Try these. Read the two statistical studies below and answer the following questions. 3. Imagine that our college is having financial problems. The college announces that it will shorten library hours to save money. The library will be closed nights and weekends. Some students think that it's okay to pay a $20 fee to college to keep the library open nights and weekends. We are interested in learning about the proportion of students who would pay a $20 fee to keep the library open nights and weekends. To investigate this question, we select a sample of 100 students. We ask each of the students whether he or she agrees with the $20 fee increase to keep the library open nights and weekends. Very well. We have some questions to ask. Does this study ask a question about population or about cause and effect? B, is this an observational study or experimental study? C, suppose that we collect data by asking 100 students who are entering the library whether they would pay the fee. Would this sample be representative of all students on campus? D, suppose that we collect data by asking 100 students who we find hanging out in the school gym if they would pay the fee. Would this sample be representative of all students on campus? E, it's important to obtain a sample of 100 students that is representative of students at the college. In question 3C and 3D, you read about some ways to collect 100 students or select them. Now think of a better way to select 100 students than the ideas in questions 3C and 3D. So instead of going to the library, instead of going to the gym, what other ways are there to collect a random sample? Why do you think your way is better? When you answer the question, be sure to think about 1, the population of interest, 2, your sample of 100 students, and 3, the type of research questions is being asked. Very well. We are on page 11. So first of all, is this a cause and effect or is this a question about population? B, observational or experimental? C, asking students who are entering the library, is this a good idea or not? C, D, asking students who are at the gym, is this a good idea or not? And E, what are other methods to collect the data? So first of all, we're just asking a question. Would you pay the fee or not? I'm not asking about if paying the fee has the effect of the library being open or not. That's a totally different question. This is a question about population. Will you pay the fee or not? Yes or no? Experimental, do we have any treatment here? Are we changing our free variable, then measuring our dependent variable? Of course not. It's just observing. Observational study. We're just observing by asking questions we collect the data, and then we're done. So asking students who are entering the library, this is not a good method. Why is that? Of course, people who are going to the library gladly pay the fee. So in this case, you get a biased sample. So this is not a good method. Asking students who are going to the gym, of course, it's convenient for me to go to a place like gym and ask questions. Again, this is another method that causes a biased sample. So this method, even though it's better than the method in part C, but since it's convenient for me as a statistician, this is not a good method. Bias sample. So what other methods you suggest? One method is to ask for roster and assign a number to each student. So give an equal chance to everyone in the college. Then select a random sample from that roster. Select some random numbers. This is one of the best methods in collecting a random sample. Let us move on to the next page, page 12. 4. We are interested in learning whether jogging for longer amounts of time decreases the resting heart rate of college students. We want to see if there is a difference between the resting heart rate of college students that jog for 30 minutes, 3 times a week for 6 weeks, and the resting heart rate of college students that jog for 15 minutes, 3 times a week for 6 weeks. To investigate this question, we will use 100 college students who do not currently jog and who have volunteered to participate as subjects in this study. Resting heart rate of each subject will be measured at the start of the study. 50 of the students will participate in jogging program where they get together 3 times a week and jog for 30 minutes. The other 50 students will get together 3 times a week, but will only jog for 15 minutes. At the end of 6 weeks, resting heart rate will be measured again. So resting heart rate as dependent variable. It's changing. Answer these questions. A, what is the research question? B, does this study ask a question about population or about cause and effect relation, jogging and resting heart rate? C, is this an observational study or experimental study? Are we changing our independent variable, jogging time, then measuring our dependent variable, resting heart rate, or not? D, imagine that we create the 2 groups for this study according to age. We group the 50 youngest volunteers in the 30 minutes jogging group. We group the 50 oldest volunteers in the 15 minutes jogging group. Is this a good idea? Is this bias? E, imagine that we create the 2 groups for this study according to weight. We group the 50 volunteers that weigh the most into 30 minutes jogging group. We group the 50 volunteers that weigh the least into the 15 minutes jogging group. Is this a good idea? And F, we need to divide the 100 volunteers into 2 groups so that there is a fair comparison between the 30 minutes and 15 minutes jogging groups. What would be a better way to divide the 100 volunteers into 2 groups? Why would your way be better than to divide the volunteers by age or weight? There you go. So here we have some questions here. So let's write them down for 4. And we are on page 12. So is this cause and effect, or is this a question about population? Part B is asking is observational or experimental. Part C, sorry, what's the research question? Is part A. So let's erase the whole thing. Cause and effect. Or just a question about population, C. Observational. Experimental. So this is dividing the groups based on their age. Dividing based on their weight. Other methods. So research question, in this case, showing a relation between 2 variables. You can ask a question like this: does jogging for longer time decreases the resting heart rate of students? A sample research question that shows a relation between 2 variables. As you can see, it's a relation between 2 variables, jogging time and resting heart rate. So it's cause and effect between 2 variables. This is observational, experimental. We are doing some experiments. It takes time. We do the jogging, then we measure the response variable, which is the resting heart rate. So it is experimental. Dividing based on age, not a good idea. Dividing based on weight, of course not. It's not a good idea. Other method, again, we can number 100 students randomly select 50 of them and form 2 groups the best way. Let us get back to our note. We are on page 14. Drawing conclusions from statistical studies. The fourth step in the statistical process is drawing a conclusion and communicating the results. When making a conclusion, researchers extend beyond the data that are observed to explain what they learned from the study. There are 2 types of conclusions that might be made from a study. One type of conclusion is generalizing from a sample to a population. Note that researchers always seek to study a representative sample of a larger population. When researchers draw this type of conclusion, they are confident that what they observed in the sample is true for the larger population. The other type of conclusion is cause and effect. This conclusion arises from an experiment when a change in a response-dependent variable was caused by the manipulation of an explanatory variable or independent variable. If a researcher manipulates a variable and this change generates an effect or response, the researcher can conclude that the change was due to the variable manipulation. The table below summarizes when each of these types of conclusions is reasonable. Type of conclusion: generalize from sample to population, reasonable when observational study is conducted and the sample is representative of the population. The second type of conclusion, cause and effect, reasonable when experiment is conducted and groups assigned to experimental conditions are similar. Well, the best way to choose a sample that is representative of the population is to use a random sample from the entire population. The best way to ensure similar groups from different experimental conditions is to use random assignments to the experimental groups. In addition, if an experiment uses both random assignment and a random sample from the population, we can draw a cause and effect conclusion and apply it to the larger population. We will see more about these ideas in upcoming lessons, but without a random sample in an observational study or a random assignment in an experiment, no conclusions can reliably be drawn.